Welcome to the T-Flow channel. In this tutorial, we simulate laminar flow around a circular cylinder using ANSYS Fluent. Before we start, make sure to subscribe to the channel and like the video if you want to see more CFD tutorials like this one. This is a classical benchmark problem in fluid mechanics and computational fluid dynamics. The flow is considered two-dimensional, incompressible, and laminar. A circular cylinder with a diameter of 0.02 meters is placed inside a rectangular computational domain. The inlet velocity is set to 0.1 meters per second, resulting in a Reynolds number of approximately 130, which lies in the laminar flow regime. The computational domain is chosen large enough to minimize boundary effects. The inlet is located 5D upstream, the outlet 15D downstream, and the top and bottom boundaries are placed 5D away from the cylinder. In this video, we will go through the geometry creation, solver setup, and post-processing step by step. We start by opening Fluent. We set the analysis type to two-dimensional. Next, we open Design Modeler. We select the sketching plane and begin by drawing the cylinder. At the center of the coordinate system, we draw a circle with the specified diameter. Now it is time to define the computational domain. To create the domain, we draw a rectangular region, as shown in the video. We define the domain dimensions relative to the center of the cylinder. We also apply a symmetry condition with respect to the x-axis, meaning the distance from the upper boundary to the x-axis is equal to the distance from the lower boundary to the x-axis. Next, we convert the sketch into a surface. From the concept menu, we select Surface from Sketches, choose the appropriate sketch, and click Apply. We then generate the geometry to apply the changes. This geometry now includes both the fluid domain and the cylinder. Optionally, from the surface body settings, we can select fluid instead of solid to avoid potential issues later in Fluent. This step is optional but recommended. In order to generate a structured mesh for this geometry, the domain must be divided into several subregions. I will provide a complete and detailed tutorial for mesh generation of this geometry in a separate video. The link to that video is provided at the top of this video and in the description. To obtain accurate results, we need a very fine mesh around the cylinder, so that the velocity gradients near the surface are properly captured. Next, we create the name selections. As shown in the video, we define the inlet and outlet boundaries. After that, we update the mesh and move to the setup section. We enable double precision and start Fluent. Due to the low inlet velocity, the flow remains within the laminar regime. Before running the simulation, make sure that the laminar viscous model is selected. The working fluid is air, which is already defined by default in the materials section. In the boundary conditions menu, we select the inlet and set the inlet velocity to 0.1 meters per second. The outlet boundary is set to a gauge pressure of 0 by default. For the solution method, we use the coupled scheme. In the monitors section, we set the residual convergence criteria to 10:6. We initialize the solution using hybrid initialization. Alternatively, we can use standard initialization from the inlet. We start the simulation with 200 iterations. Due to the simplicity of the problem, the solution converges very quickly. To visualize the velocity and pressure fields, we move to CFD Post. we create one velocity contour and one pressure contour, as shown in the video. Both the velocity and pressure contours should be symmetric with respect to the x-axis.